Here are 10 volcano facts you can listen to in English. Now, let's get started. Blue lava volcano. Imagine a volcano that spews rivers of electric blue fire instead of the typical red lava. At Indonesia's Ei-Chan volcano, this extraordinary natural phenomenon creates an illusion of blue molten rock flowing down its slopes. This surreal spectacle is not caused by the lava itself, but by the combustion of high-temperature sulfuric gases that escape from volcanic cracks. When these gases, under intense pressure and heat, meet the oxygen in the air, they ignite and burn with an ethereal electric blue flame, illuminating the night landscape. Strictly speaking, the molten rock is not blue. It retains its normal reddish glow. The phenomenon is the light emitted from the burning sulfur, a process that is only visible in the darkness of night. As the gas cools, it condenses into liquid sulfur, which continues to burn blue as it flows down the mountain. This unique geological site is not just a tourist attraction. The cooled, bright yellow sulfur deposits are collected by local miners in a physically demanding operation, supplying sulfur for commercial use.
Loudest sound in history. What was the single loudest sound in recorded history? It was not a man-made explosion, but the 1883 eruption of the Krakatoa volcano in Indonesia. The cataclysmic blast was so powerful that it was heard clearly from 4,800 kilometers away. The atmospheric shock wave generated by the eruption was detected by barographs around the world and is said to have circumnavigated the globe 7 times. The event also triggered a devastating tsunami with waves reaching a height of 40 meters, resulting in the deaths of more than 36,000 people. The eruption's consequences were not limited to the immediate vicinity. The massive amount of ash and aerosols ejected into the stratosphere spread globally, causing a noticeable drop in average global temperatures. This atmospheric debris also produced spectacular, intensely colored sunsets that were observed worldwide for several years after the event. A prominent theory suggests that these vivid, blood-red skies served as the inspiration for the dramatic background in Edvard Munch's famous painting, The Scream, created a decade later.
Ice volcano on Enceladus. Can a volcano erupt ice instead of molten rock? On Saturn's moon, Enceladus, this is exactly what happens. From long cracks in its south polar region, known as tiger stripes, plumes of water vapor and ice particles are ejected into space at incredible speeds of approximately 400 meters per second. This remarkable phenomenon, where a celestial body erupts volatile substances like water instead of silicate rock, is called cryovolcanism. The driving force behind these icy eruptions is believed to be a subsurface ocean of liquid water. Scientists theorize that the immense gravitational pull from Saturn creates powerful tidal forces. These forces continuously flex the moon's interior, generating heat that keeps the water in a liquid state beneath the icy crust. This pressure builds until the water erupts through the surface fissures, creating geyser-like plumes that shoot into space.
Europa's water volcanoes. Did you know that one of Jupiter's moons may be erupting with plumes of water reaching 200 kilometers into space? On Jupiter's moon, Europa, scientists have found compelling evidence for the existence of cryovolcanoes, or ice volcanoes. These are not volcanoes of molten rock, but rather geyser-like eruptions that spew water vapor from beneath the moon's frozen surface. The source of this water is believed to be a vast liquid ocean hidden under Europa's kilometers-thick ice shell, making it a primary target in the search for extraterrestrial life. The potential existence of these water plumes has significant implications for future space exploration. They offer a tantalizing opportunity for a probe to directly sample the contents of Europa's subsurface ocean without the immense challenge of landing and drilling through the ice. A spacecraft could simply fly through an erupting plume to analyze its chemical makeup for signs of life. Because this hidden ocean is considered one of the most habitable environments in our solar system beyond Earth, analysing these plumes could be a crucial step in discovering if life exists elsewhere.
Volcanic Ash, Aviation Threat. Why does a cloud of seemingly harmless dust from a distant volcano pose a catastrophic threat to modern aircraft? Volcanic ash is the nemesis of aviation, primarily because its main component, fine particles of glass, has a melting point lower than the operating temperature of a jet engine. When an aircraft flies through an ash cloud, these particles are ingested into the engines, which operate at temperatures exceeding 1100 degrees Celsius. The glass melts and fuses onto the turbine blades and other critical engine components, disrupting airflow and causing a rapid loss of thrust, which can lead to engine failure. The 2010 eruption of Iceland's Eyjafjallajökull volcano provides a stark example, leading to the cancellation of approximately 100,000 flights across Europe. The danger is compounded by the difficulty of detecting volcanic ash in the air. The particles are too fine to be picked up by standard onboard weather radar systems, making avoidance a significant challenge for pilots. Consequently, the aviation industry has established strict safety protocols, defining airspace as hazardous when ash concentration exceeds 2 milligrams per cubic meter. To ensure safety, airlines are heavily reliant on forecasts from volcanic ash advisory centres, which use satellite data and atmospheric modelling to predict the movement of ash plumes. This predictive capability is crucial for rerouting flights and preventing potentially disastrous encounters with these invisible airborne hazards.
Martian Giant Volcano. Did you know that the largest volcano in our solar system is not on Earth, but on Mars? Towering over the Martian landscape, Olympus Mons has a height of approximately 25 kilometers, making it nearly 3 times taller than Mount Everest. Its base is so vast, with a diameter of about 600 kilometers, that it would almost cover the entire main island of Japan, Honshu. This massive shield volcano is a testament to the different geological processes that have shaped the planets. The immense size of Olympus Mons is primarily due to Mars's lack of plate tectonics. On Earth, tectonic plates are constantly moving over stationary hotspots in the mantle, which results in the formation of volcanic island chains like Hawaii. In contrast, the Martian crust is static. A single hotspot was able to continuously erupt lava in the same location for a tremendously long period, allowing the volcano to grow to its colossal proportions without the crust moving away from the magma source.
Supersonic Diamond Volcano. How did diamonds, formed over 150 kilometers deep within the Earth's mantle, ever reach the surface? The answer lies in an incredibly violent and rapid volcanic eruption that traveled faster than the speed of sound. The geological remnants of these ancient events are known as kimberlite pipes, most famously found in Kimberley, South Africa. These structures are the conduits of a unique type of magma that rocketed to the surface, carrying its precious cargo of diamonds from extreme depths in a single explosive journey. The phenomenal speed of this eruption was absolutely critical. The entire ascent from the mantle to the surface is believed to have been completed within just a few hours. This rapid transit provided insufficient time for the diamonds, which are a high-pressure form of carbon, to transform into graphite, their far more common and stable low-pressure counterpart. Furthermore, the magma itself possessed a special composition, being unusually rich in carbon dioxide, which likely contributed to the eruption's explosive power. This rare combination of speed and chemistry is what preserved the gems and delivered them to us.
Volcanic lightning. Can a volcanic eruption generate its own powerful electrical storm? For certain violent eruptions, the answer is yes, in a phenomenon known as volcanic lightning. This dramatic display is not caused by weather systems, but by the eruption itself. Inside the turbulent plume of smoke and ash, countless particles of rock, ash, and ice crystals collide and rub against one another at high speeds. This intense friction strips electrons from the particles, creating a massive separation of positive and negative charges, which generates enormous static electricity. When this electrical potential becomes too great to be contained, it is released as a spectacular lightning discharge within the ash cloud. Beyond its visual spectacle, volcanic lightning serves as a crucial real-time monitoring tool for volcanologists. The frequency and intensity of the lightning strikes are directly related to the characteristics of the eruption plume. By analyzing the electrical activity, scientists can estimate the height of the plume and the concentration of volcanic ash it contains, without relying solely on satellite or radar data, which can be delayed or obscured. This information is vital for aviation safety, allowing authorities to rapidly assess the eruption's scale and issue timely warnings to divert aircraft from hazardous ash clouds.
Antarctic Active Volcano. Did you know that the Earth's coldest continent hosts a volcano with a permanent lake of fire? This is Mount Erebus, the southernmost active volcano on our planet. Reaching an elevation of 3,794 metres, its summit crater is home to one of the world's few persistent lava lakes. This convecting pool of molten rock constantly churns at temperatures exceeding 1,000 degrees Celsius, presenting a dramatic spectacle of fire in a land of ice. The interaction between this intense volcanic heat and the surrounding polar environment creates unique geological phenomena. Although the mountain is covered by a thick ice sheet, its geothermal energy melts the ice from below. This process forms an extensive network of ice caves, often referred to as ice fumaroles. Hot volcanic gases travel through these icy passages, creating a remarkable subterranean system where extreme heat and sub-zero temperatures coexist.
Solar-poured ice geysers. Can volcanic activity exist on a world where the surface temperature plummets to a frigid -235 degrees Celsius? On Neptune's largest moon, Triton, a unique form of cryovolcanism is powered by the faint light of the distant sun. In this extreme environment, sunlight penetrates the translucent surface layer of frozen nitrogen. This minimal solar energy is enough to heat the nitrogen ice below, causing it to sublimate or turn directly from a solid into a gas. As pressure builds beneath the icy crust, it eventually erupts through weaker points on the surface, blasting plumes of nitrogen gas and dark dust up to 8 kilometers into space. This remarkable process was one of the most surprising discoveries made by the Voyager 2 spacecraft in 1989. While other moons, like Saturn's Enceladus, also exhibit cryovolcanism, their activity is driven by internal heat generated by tidal forces. Triton's geysers are distinct because they are powered externally by solar energy, despite Neptune's orbit being about 30 times farther from the Sun than Earth's. The dark, carbon-rich material carried aloft by these eruptions is then swept by Triton's thin atmosphere, creating long, dark streaks on the Moon's surface that provide visible evidence of this otherworldly volcanic process.